Here we go. So we're going to start recording here. And what we're going to be talking about today is it is essentially going to be the distributive property. And what I want you to see when we talk about this, we're going to be talking about the distributive property and variables. Because a lot of times what happens, and I don't want you to get confused about any of this stuff. What's going to happen when we do this, I think you're familiar with it, but there's a couple things that I want us to kind of deal with. Let's start with just the straight up distributive property, okay? Distributive property is what happens when you use a set of parentheses and inside the parentheses you have more than one thing. Now, most of the time when we're talking about terms, we really only have two, but you could have like a million things. They just have to be separated with a plus or a minus. I'm going to start off with a plus, and let's go with, I'm going to put a really simple expression here. Let's go 2x there. I'm going to say plus 3. So we're just going to have two things here. Now, here's what's important inside the parentheses. These cannot be like terms, okay? So if they can be combined, like if it was a 2 and a 3, we're not really using the distributive property when you do that because you can always put them together. So when you're dealing with this in algebra, you normally have something with a variable here. You got something else with a non-variable here, so they can't be combined. And then for it to be the distributive property, you're going to have something on the outside of these parentheses to be able to distribute. Now, I'm going to put a 5 here. And so what this is that I'm going to be doing is multiplying this number from the outside times both things on the inside. Now, when I have done this in the past, I believe that the way that I have written this has been, I call them like the swoops, where I do like this number here and this number here. And then what that means we're doing, well, you tell me, when I do that, what am I doing with that 5 and the things on the inside here? You guys remember? Multiply the 5 by the inside numbers. Yeah, so like what that means we're going to be doing is we're going to be doing that the 5 times 2x plus the 5 times the 3. And so that when we're done with this, the two things that we're going to have when we're done is going to be, well, the 5 times the 2x is 10x, plus the 5 times the 3 is 15. We're still going to have two different terms that don't combine, and we're going to be done. Now, how many of you recall this and you feel like, okay, I remember what's going to be happening here? If you feel like you get this, say, I do. If not, that's fine. I'm going to go through some more examples to show you some things. I got two people that said something. I got me and I got me. Anybody else that feels like they get this and they remember it? 3, give me a fourth and I'll move on. One more person has to tell me they get this and I'll be ready to move on to the next thing. And so we sit. Nobody else is going to say I do or me to let me move on to the next thing. There we go. Look at that, guys. Thanks. So here's the thing. The first thing that I want to show you is we have a different way of writing this that's going to help us as sort of like a graphic organizer for the way that this works when we start to make it a little bit more complicated. Because what we're going to be talking about tomorrow is how would we distribute things that are more complicated than this. I want to show you the graphic organizer so that you kind of see what's happening here. On the outside of this, I have one term. And what I mean by that is I'm just dealing with, I'm taking a 5. There's just one thing there. There's not more than one thing. On the inside here, how many terms do I have? How many terms are inside the parentheses here? Somebody's got to write something. How many terms do I have in here? If you're wrong, I'll correct you. It's okay. 2 terms, absolutely right. 2x and 3, because I can't combine them. There are 2 unlike terms in here. Here's what that helps me with. That is going to give me a way of doing this graphic organizer. And what I do, this essentially is telling me how I make the rectangle that I'm going to use to organize this work. Now, you've already done the math. You know what the answer is. So what I'm going to show you is how we do a 1 term by 2 term. So the first thing, 1 by 2 is what I'm going to make when I make this rectangle. Wow, this is dead. I'm not going to use this pen anymore. All right, so 1 by 2. What that means here is that we're going to make a rectangle like this. On the side that I have a 1, I'm going to write my 1 term. That 5 is going to be right here on the side, okay? On the place where I've got the 2 terms, I'm going to write those across the top here. I'm going to write that 2x, and I'm going to write that plus 3. Now, the reason why I have this written in a graphic organizer format is because what this gives me a way of doing is of organizing where my answers are going to be. Now, with a straight up distributive property like this, it's not super useful. It's just kind of a way of organizing it. What we're going to start to do tomorrow is deal with things where we have more than 1 term times more than 1 term. And having something that is a larger graphic organizer is very helpful to figure out what it is that you're supposed to do and keep track of it. Today, let's just practice it on the smaller scale so we know what's going to happen here. So again, we use this like a multiplication table. And that means when we distribute this, I just write my answer here. 5 and 2x pair together for this one. 5 and 3 pair together for this one. So 5 times 2x is what goes in here. Tell me again, what's 5 times 2x? 10x is correct, so that goes in this box. And then in here, it's going to be the 5 times the 3, which gives me what? What's going to be right there? 15. So once I fill in those 2 boxes, I can then say that my final answer is this plus this, because they're not like terms. So 10x plus 15, that's my answer. And dude, I already knew that from here, but it gives me another way of organizing it. Now, I will tell you what they call this. They call this the area model of multiplication because they think about this as like a rectangle where this is like our length and this is our width. And so here, this is length times width that tells me the area of this, and this is length times width that tells me the area of this one. That's fine. Ultimately, I like thinking of it as a graphic organizer and a multiplication table, but however you want to think about it, it's okay. This is kind of the way that we do this. And so what I want to talk about today and what we're going to be doing mostly through this today, some examples doing the distributive property using the graphic organizer here, using the box, is I guess the way I call it, the box method of multiplication. And then I'm going to do this with changing some variables a little bit so we can talk about this and maybe even throwing some like decimals in here, just so you can see that the function is always the same. It's just a matter of how do we go about doing it, okay? So before I get started and really kind of dig into this, does anybody have any questions about sort of what I'm doing here, or does this seem to make sense? So like if you got a question, throw it out there now. But if not, if it seems to make sense, say I'm good, and that lets me sort of move on. This gives me a chance to take a sip of coffee. I got an I'm good, solid. Anybody have a question about this before I roll? Okay. So let's just kind of go with what we're talking about here. I'm going to use the next little space here, and we'll use different colors. I think I've been using the same pens, and they're starting to all wear out. So hey, let me start with this. If I give you, we'll go another pretty simple one. Let's go 8 times 3x minus 7. Okay, gives us a place to start. So again, what I tend to do first when I'm doing this, before I make the box, I just count my terms. So there's 1 term by 2 terms. So that's what my box is going to look like when I make it. So I do a 1 by 2. And then I put my stuff where it goes. So here's my question. Where's that 8 going to go? Where do I put that? On the side or on the top? On the side. Okay, so I'm going to put that 8 right over here where I've got my 1 term, which means what's going to go up on top here? What's going to go here on the top right there? 3x right there, and then here's going to be negative 7. All right, solid. So now when I multiply this together, that is going to help me out. This is also dying off. I kind of like throwing stuff in the classroom. That makes me happy. So here, I've got to multiply this together. What am I going to get right there? 24 and x, because 8 times 3 is 24. And I've still got that x there, so 24x is correct for this one. 8 times negative 7 is going to give me, Uzziah's got this, is a negative 56. Are these like terms? They are not. This has an x. This does not have an x, which means that my final answer for this is just going to be those set next to each other. 24x minus 56. Okay. Seem difficult at all? Because I'm telling you, that's mostly what we're going to be talking about today. Looking at my time, I will probably have enough time to go ahead a little bit, but we're going to see, because this is kind of what we're doing here. So what I'm going to do is just start to throw, I'm going to call them sort of like my curveballs, the things that would be like, here's what would make this a little bit different. Oh, and here's what would make this a little bit different. And here's what, so that's what we're going to try to do here. And if that is a trouble for you, this is where you're going to have to say, whoa, Bechtel, stop, relax. And then you'll ask like weird questions and I'll say, what? Hold on. So here's what I want to do. I'm going to give you another one. Let's go -4 times 5x minus 9. All right. But look at this. How many terms by how many terms? What by what? That is a 1, because there's only one term. By how many terms are in here? 1 by 2. Say 1 by 2. So if I got a 1 by 2, that's my box. 1 by 2 here. Oh, come on, pens. You can't all fail on me at the same time. I don't want to throw that one. I actually like that one. Okay. What goes on the side here? -4, because that's what the one term is. What do we have on this top and this top? 5x there, -9 here. Bryson, if you got issues, brother, I will be happy to answer your question. Okay, so we got 5x and we got -9. So let's think about what happens here then. If I multiply those two together, what am I going to get right here? Okay, so Jemiah, you've got that correct. It's the -20x. The thing that I want to point out with this, what tends to be an issue, Bryce Ed, stay with me, man. We're talking about this. If I'm multiplying those two together, remember that -4 times that +5, that is going to give me my -20. And I've got to remember that the sign that we're dealing with here is going to go along with what we're dealing. So negative times a positive is a negative. And that x is there, so I've got to include that as well, -20x. What about this one here? Uzziah's got this, a negative times a negative is a positive. So if I do -4 times -9, what am I going to get right there? -4 times -9? We know it's a positive, right? So I'll do a little plus there. 36 is correct. And guys, here's the thing. Please use your calculators when you do this. Use your phones to type them in as calculators. Use whatever you need to. Because what should happen when we're done with this is we should get two terms that are not like terms, because we didn't have like terms here. And then when we put that together, our final answer will be -20x plus 36. So the curveball for that one is that you had a negative number on the outside. Totally simple. You can get through it. Just remember your negatives and your positives when you multiply. Now, here's the next thing. And I will tell you, Uzziah, in a minute, you're going to probably want to use calculators, because I'm going to tell you I won't know the answers without this. They're going to give you a problem that's going to look like, and I'll do like a double line here to say we're doing a new example. They'll give you a problem that looks like this. We'll go like 1.2 times 4x minus 3.5. Now, I'm going to tell you right now, I do not know what 1.2 times 3.5 is. That's why we use calculators, guys. I can do it by hand, but I'm not testing whether or not you can do long multiplication with decimals. I just want to know that you know how to set it up. So right now, one term times two terms, I'm going to make this box just like this. When I set this up, you can tell me what goes out on the side here, right? What's this going to be? And settle down, Jemiah, it'll be fine. 1.2. And then across the top here, I'm going to have 4x there. I'm going to have -3.5 here. Now listen, all you have to do, and I'm telling you right now, you see my phone, I'm going to use this because I really don't know what that is going to give me. I also don't exactly know what 4 times 1.2 is. Actually, I got a better idea with that one. But so when I do this, clear it out, 1.2 times 4, that is going to tell me what I have in here. So in this one right here, I'm going to get 4.8, because that's 1.2 times 4, x. 4.8. Boom. All right. Now for the next one, 1.2 times negative 3.5. First off, is it going to be a positive or a negative number? Got to be a negative, because I got positive times a negative, so it's going to be a minus. Now, if I do this, 1.2 times 3.5, I didn't even do a negative. This last one, Janae, that's going to be my 4.2. You're right. So in this case, 1.2 times 3.5 is 4.2 when I'm done with that. So negative 4.2. Now, you notice how I don't have a negative sign here? Oh, you guys can't see that because my camera here. You notice how I don't have a negative sign there? It's because I didn't multiply it by a negative one because I forgot. I had put it here. As long as we remember that we've got the negative there, we should be fine. These are not like terms. So when I'm done, it's going to be 4.8x minus 4.2. Now, guys, I would never, ever expect you to do something like this by hand. That is not what we're doing here in Algebra 1. In Algebra 1, it's can you put this together and can you go through and do this? So what I want to show you is why, when I called this in the notes, the distributive property with variables, I want to make sure that you understand something really quickly. Something they could do. I'm about to move from decimals, okay? Well, I'm glad that you did that without using a calculator, but you called me bruh. I don't know what to do with that. That's actually, I do. Bruh. I'm proud of you. Good job. What if I gave you this? Could you help me set this up for a minute? It is a bruh moment. If I set this up with my 1 by 2, what goes out here? What goes right there? 2x, absolutely correct. What about on the top here? That's a 3x. What about here? Negative 4. Now, guys, it's time to pay attention. If you have not been paying attention, I don't know why. This has been like gripping. This is like the best show you've ever watched, as you're watching right here. I can't even keep that serious. I'm sorry. When we multiply variables together, we cannot forget that it's a little different than if you just multiply variables numbers. So like right now, yep, Uzziah, you got this. Dealing with this part first, that 2x times that negative 4, I know you can get that. Negative 4 times 2x is negative 8x. That is no problem. I also know you could tell me what 3 times 2 is. 3 times 2 is just 6. What you have to remember is when you're multiplying variables times variables, you got to start to use exponents. So that if I have an x times an x, I have to write that as x squared. So this is 2x times 3x. This is going to be 6x squared as the result. And the reason why that's important is because I keep asking you if these are like terms, because if they are, I have to combine them. If you forget to multiply the two x's together, and this gave you 6x and negative 8x, those would be like terms that could combine, and I would get that answer. These aren't like terms because that's a squared and that is not a squared. And so when we put this together, what I want to make sure that you understand is that when we get some of these different values, I still just write those next to each other, 6x squared minus 8x, and I'm in good shape. But if you don't remember the squared, then you will do something wrong, and I don't want you to make that mistake, okay? So this is sort of the last twist of things that you might have today, is something with a variable outside and a variable here. So that you just have to remember, all this does is that when we put two x's together, it's x squared. When we put an x with something that doesn't have one, we just have to write it as an x, okay? Now, how do you feel about this right now? Is everybody okay so far? Give me a thumbs up if you're okay. I mean, you could do a thumbs up, but you could also, actually, I haven't looked at this yet. Can you guys do that little reaction thing in your screen? So if you got it there, I'm gonna look and see if I can see how many of you guys can actually do a thumbs up on that little reaction at the bottom. Anybody got this? I got a couple thumbs up. Anybody else? There's only 2? There's 3? Well, if you don't have a thumbs up, I guess that's fine. Okay, so here's what I want you to do. What I want to show you is how this points to what we're going to be doing tomorrow. And I think as a preview for what we're doing tomorrow, you're going to go, oh, that's super easy. And I agree if you feel that way. But I just want to make sure, okay, right now, we've covered everything you need for today. You've really gotten it, but this is what we're going to do tomorrow. Tomorrow, what we're going to do is see what happens when we multiply 2 terms by 2 terms, okay? And it isn't difficult, but it is something that's a little bit, it takes a step a little bit further. This is a 2 by 2, right? So when I make this, I'm not just doing one thing anymore. And that's the part about this that's important. I'm making a 2 by 2 rectangle so that when I do this 2x and this 3, I'll put the 2x here, I'll put the plus 3 here on the side. That 3x plus the 5 now goes here. So that when we multiply this, instead of just getting 2 answers, I'm going to get 4 because I'm essentially saying I'm going to take this 2x and multiply it by both of them. That's up here. And I'm going to take this 3 and multiply it by both of them, and that's going to be down here. And then I got 4 terms to deal with. This is the way we're going to be dealing with things when we multiply a 2 term by a 2 term, okay? Now, to get to the answers, it's not difficult. It's the same thing that we did before. 2x times 3x, we literally did this with the last one. It's 6x to the second power. Now, what, Uzziah, you cannot get me off track like that. 2x times 5, what's this going to be right here? What is 2x times 5? Somebody's got to tell me. 2x times 5, what do we get if we put that right here? 10x is absolutely right. What about 3 times 3x? What do we get here? That's 9x. And then for this last one in the corner, what's that 3 times the 5 going to give us? 15. So we've gotten 4 answers here, which it's fine. That's totally cool that we have 4 answers. But like what we've done before when we've had 2 at a time, I want to make sure that you recognize that we're going to be combining like terms here to be able to get a final answer. And so when I write my final answer out to the side, I take them one at a time and check. 6x squared, there are no other x squareds here. So that I just write. There's nothing else I can do with that. That's just stuck there. This 10x and this 9x combined, Uzziah, you said that. That 9x and that 10x are like terms. So if I combine them, 9x plus 10x is going to equal 19x. So that takes care of both of theirs. And this 15, there are no like terms with that, so I write that on its own. So we're going to get what's called a trinomial, 3 terms, by multiplying 2 binomials together because those are 2 terms. This kind of leads us into what we're going to be doing next, but I wanted to make sure that you'd see it because it's a little bit weird, and it is something that I wanted you guys to be able to see. It's not difficult, especially if you understand the stuff that we did first, but it is something that I want to make sure that you guys have kind of seen. So with that being said, I want to do this. I am going to stop the recording.